So we're looking at a very similar question now, except instead of the sum of two functions, we're looking at the difference of two functions. The difference is what we get when we subtract two functions. So f of x is the square root of x minus 1, g is x minus 2. We can't actually do any combining to that because the x minus 1 is under a root. So h of x is square root of x minus 1 minus x minus 2. We have to have the x minus 2 in brackets because we're subtracting the whole function. If we were to simplify that out, we could distribute the negative in, like so. We can do the calculations, complete the table, start with minus 2, substitute minus 2 to f. We get square root of minus 2 subtract 1, which is the square root of negative 3. That is something that does not exist. Substitute in minus 2 in for g, we get negative 4. And something that doesn't exist, subtract negative 4, still does not exist. We're going to end up with the same situation if we plug in both negative 1 and 0 into f. We get a square root of a negative, which we can't do. So there's no sense even bothering to calculate out g, since neither of those two will exist as well. Move on to 1, substituting 1 in for f, square root of 1 minus 1, square root of 0. That actually does exist. It's 0. Plug in 1 into g, we'll get negative 1. And this is the point that we need to be careful because we're doing f minus g, 0 minus negative 1, which would be 0 plus 1, which would give us 1. Plug in 2 into f, we'll end up with 1. Plug 2 into g, we get 0. 1 minus 0, also 1. Plug in 5, in for f, we'll get 2. In for g, we'll get 3. 2 minus 3, negative 1. Plug in 10 in for f, we get 3. 10 in for g, we get 8. 3 minus 8, negative 5. Again, the graphing part, f I'll do in red. We've got first point at 1, 0, point at 2, 1, another point at 5, 2, and last point at 10, 3. Now, this graph has a hard stopping point at 1, 0. It doesn't continue on past that to the left. So it is just a graph like that that continues on in one direction only. G, we'll do in yellow. Now there's a couple of points that we didn't find, but that's okay, we don't need them. G is going to make a line anyways, because it's just an x minus 2. Put down the points we have, negative 2, negative 4, 1, negative 1, 2, 0, 5, 3, and 10, 8. Those line up rather nicely. Try that again. H, again, we have a few points that are useless to us, but we have a point at 1, 1. We have a point at 2, 1, a point at 5, negative 1, and at 10, negative 5. So H, like F, has that hard stopping point on the left. It'll look something like that. Question C, the domain of h of x. Domain is not any real number because the domain actually starts at 1. So x's would have to be greater than or equal to 1. D, the range, we have to approximate it since we do have that little loopy bit at the left side of h. What we do know is that y will be less than or equal to because it goes down. I'm going to say approximately maybe 1.2 would be the high point.